Hello, it's Keith here, and this is lesson 14 of the simple series of my Z80 assembly tutorials. We're going to be looking at the SAM Coupe this time, and we're going to be adding key reading to the sprite example we made last time. We made a smiley face before, and we're now going to move that smiley face around with the keyboard using QA, O and P. So let's just start off straight away and let's see the example running. We'll just start this up here. So you can see we've got our smiley face, and if I use QA, O and P, you can see it's moving around quite quickly thanks to the 6 MHz processor of the SAM. Now if I hold down a key here and try and go off the screen, you can see I can't. So the point is here, we've got a basic sort of starting point for some kind of game. We can read in keys and we can draw sprites to the screen. So we're going to go through the code here and we're going to see how most of it works. We're not going to look at the bitmap part because we looked at that in a previous lesson, and I don't want to go through the exact same code another time. So please take a look at that if you need to see the full details of this. Okay, so how does the program start? Well, we've got an origin here at 8000, which is where I load my program into. We're defining a stack pointer, and then we're defining the bank that's going to be used for the visible screen. And we're defining banks 14 and 15 here, which are the highest banks within the 256K system here. So that's what we're defining there. And then we're jumping down to here. The reason we're jumping over this part is this is the key reading part, and it will wait for a key. But the first time we need to draw the starting position of the character. So we're just setting the key presses to 0 and we're jumping over to here. When we want to read in the keyboard, I'm using this function call to the operating system of hexadecimal 169, which will read the keyboard and flush the buffer, and it returns the key within the accumulator here. And so we're just looping there until a key is pressed. The start drawing routine is here, and this first backs up the player's position. Now the player's position is stored in a pair of bytes here, just in system memory, and we've got a backup pair here for the last position. You can also see we've got our sprite drawing routine here. Draw sprite is basically the smiley face routine we looked at before. Blank player is just almost the same. We're just using a different empty sprite here just to clear the background so that the sprite disappears. So what we're doing here is we're backing up the current position of the sprite, and then we are clearing the old sprite position here because we're assuming we're going to move the sprite, and then we're restoring the value we read in from the keyboard here from the accumulator, backing it up into D, and we're comparing with our 4 key presses Q, A, O and P here. And each time we've got B and C, which are our current position. We read them in here. And if the up key is pressed, then we will run this code and subtract 2, moving us up the screen. But if it's not pressed, we'll jump over that to here. And the same with down, and then left, and then right. So each of these is moving the B and C X and Y positions according to any key presses that have occurred. Once we get to here, we then save the new position in the X and Y variables again in memory. And now what we need to do is we need to check if the position of the player has gone outside the valid areas of the screen. Now the top left hand corner of our screen is 0, 0. The width of our screen is 128 bytes, but our smiley face is 4 bytes wide. So the width we're checking against is 128 minus 4. The height is 192 lines, and our sprite is 8 lines tall. So that's our comparison here. Either way, if our sprite is in a valid position on the screen, we end up here. If it's not, then we end up jumping to this player reset. The player reset gets the old value for the X and Y position and stores them back into the current position and updates our registers here. We then call the draw player to show the sprite to the screen. What we do next is we pause for a while because this code would be too fast otherwise, and then we jump all the way back up to the top to repeat. And that's all there is to it. Now this example is using QA, O and P, but the SAM Coupe will actually emulate a cursor joystick which will use the numeric buttons as the joystick buttons if you have that hardware. But I thought it was a good idea to start with just QA, O and P in this example because that's kind of the classic Spectrum key presses, and the SAM Coupe is very much based on the Spectrum originally, so that made some sense to me. So there we go. That's how you can get the SAM Coupe reading keys, and we've now seen how to make sprites onto the screen as well, which should be a good starting point for you to make a little game. If you wanted to add sound later on, you should see my GB Sound series where we looked at sound on this system, and it shouldn't be too hard for you to incorporate that code into this example if you want to take it further. But hopefully this will give you enough to get started and make some progress. I'd suggest you might want to look at copying the code and creating a second player, maybe a computer controlled one, or you could read in from the keyboard and the joystick and have 2 control players battling each other in some way. Anyway though, if you're interested in this, of course you can get it from my website. If you like this kind of content, please like and subscribe. I'll be covering the Sam Coupe again in the future, and I've got lots of other episodes on the Sam Coupe already. So if this is the kind of thing you like, please follow along. Anyway, hope you found this interesting. Thanks for watching today, and goodbye.